So today we're going to be determining the value of X, or the number of waters, in the formula for this calcium sulfate hydrate. And we've been given this laboratory data, typical of most hydrate lab data, in which you have a dish, which is empty. We have to know the empty dish. The dish plus the hydrate. So imagine something going in to the dish and the mass goes up, obviously. Then we heat it and the water escapes out the top of the container. And because water is escaping, the mass goes down. Now, in order to find the formula of a hydrate, you're going to be doing the same steps as finding an empirical formula. You're going to need to know the mass of each part. The calcium sulfate, which is the anhydrous part, and the water, which is the hydrous part, or the actual water. So, using our lab data, how are we going to get the mass of the calcium sulfate? Well, the calcium sulfate, the anhydrous, is what's left at the end, this 39.08. But that includes the weight of the dish. So I don't want the weight of the dish in there, so I'm going to end up subtracting those two masses to get the grams of calcium sulfate. Okay, well, and let's just go ahead and do that. So 39.08 grams minus 34.22 grams is going to give me 4.86 grams of calcium sulfate. And that's the anhydrous. So that is the mass of this part of the formula. To get the mass of the water, we have to do another subtraction. And that is the subtraction of what it weighed before with what it weighs at the end. The mass went down during heating because the water was driven off, and so simply subtracting those gets us where we need to be. So let's do that. 40.37 grams minus 39.08 grams gives me 1.29 grams of water. Okay. So I've got both masses of water, or the anhydrous and the water. Now the steps are really the same as empirical formulas. I need to take these masses and change them into moles. Okay, and we would do that because we have a periodic table handy. We could go to the periodic table and look up the masses of the two compounds, unless you have them memorized, which of course would be very nerdy. Well, most people don't have them memorized, so we would go and find out the masses of 1 calcium, 1 sulfur, and 4 oxygens and add them up. And we would get a mass of 136 grams per mole. Water, we would do the same way. 2 hydrogens and an oxygen will add up to 18 grams per 1 mole. And we just have to tap our calculator and get our answer. So 4.86 divided by this gives me 0.0357 moles of calcium sulfate and 0.0716 moles of water. Now again, we're not at whole numbers yet. We want to get there. We're almost there, but we're not there quite yet. We want the lowest whole number ratio of these two numbers. And again, just like empirical formulas, we need to just divide them both by the smaller one. Which automatically makes the 1 into a 1. And the other one comes out right about 2.01 according to my calculator. So, wow, we don't have a whole number yet. But you know what? You might be looking at that number going, well, that's pretty darn close to a whole number, right? Yes, it is. And at this point, we make the judgment call to round that because it's super close. And that 0.01 probably came because maybe I rounded these values, or maybe my balance was off by a tiny bit. There could be many reasons for it, but if you see a value that's really close to a whole number, just round it, call it a day. So I now have a 1 and a 2, which means my formula is CaSO4 dot, that's not a multiplication sign, it's a dot, 2 H2Os. The 2 goes there, and the 1 goes right there. And I'm going to highlight that for anybody reading my work. I'm going to put a heart next to it because we love it when we get a right answer. And there you have it. Calculating the formula of a hydrate using lab data.